Hello there, welcome to this season 2 of the Shieldier guide for the Damn Vulnerable Web application on medium security. If you've joined me for the previous season, low security, I hope you enjoyed, I hope you learned something. If you're new here, welcome. We do things a little bit differently. It's not just going to be your standard, here's a command, run it, hack it, happy days. Instead, I provide the red team perspective, as in how to hack these things, what commands and tools are most appropriate to be used at the time. The blue team perspective, how to defend against these things and how to detect them utilizing the elastic seam. And finally, the purple team perspective, how to automate all of that into a coherent narrative. Without further ado, let's jump right into the medium security reconnaissance for the Damn Vulnerable Web application. Much like last time, we will be using similar tooling to the low security. However, throughout the medium security guides, I will be deliberately obfuscating the attacks that we are using, such that for the detections that we developed last time on low security for the blue team perspective, we will be able to circumvent them and allow our attacks to still succeed while remaining as much as possible under the radar. Now, that's going to entail quite a few different techniques throughout this guide, but it will hopefully deepen your understanding for how these things actually work and not just, oh, yes, this is how it works. No, contraire, monsieur. These are the RFCs, this is the documentation, and this is how it must work if we're going to have a interoperable internet, shall we say. For example, throughout this Recon section, I will be describing 3 main methods to obfuscate the Nmap scanning. The basic parameters for any detection that we were going to be doing on this is if X, in Y, then Z. The first obfuscation method will be if X packets in Y time, then raise an alert. If 1,000 packets in 5 minutes, then raise an alert. Simple as that. We are going to be modifying that. So what happens if 100 packets in 5 minutes? Then what? Nothing. No alert. We've sailed under the radar. From the blue team perspective, for the most part, we're not only going to be looking at detecting the activity, but also blocking or preventing it in the first place. I will be describing how to install mod security to allow us to block the web application level threats against the Damn Vulnerable Web app. It's not obviously it's not a be all and end all solution to stop all hacks and everything in any case. There are, as I will describe in later posts, obfuscations that you could do to even bypass the default OWASP core rule set so that you can also attack if they're defended by mod security, be able to circumvent those attacks or those defenses. I will then also be providing rules that will circumvent the circumvention, if that makes sense. Now that lays the groundwork for this season 2, let's hop right in. As alluded to previously, we will be providing you with 3 methods to obfuscate the Nmap scan. The first method, just send less packets. The second method, slow the scan way down. The third and final method, send the same number of packets, but just, crucially, from different source IP addresses because Nmap provides the S flag. Now, you could set that source IP address to be some address based in Russia. If you're feeling cheeky, I wouldn't advise it because then you wouldn't be able to get the return results back. But with the method that I'll be providing today, you will be able to get the return results back because we'll be inflating into the rest of the /26 classless interdomain routing network within the Tartarus lab. The Tartarus lab is sort of how I've frameworked all of this together so that you can both attack and defend and do everything in between. And then finally, for the fuzz foster you fool, I'll be providing another method, pun intended, to be able to gather or get information from the web server without actually using the get method, because we were able to successfully infer from the status code whether or not a page is there that we are looking for. This obfuscates some of the detection logic, some of the premature optimization detection logic from the low security reconnaissance part of this guide. Prerequisites, as always, you're going to need a damn vulnerable web app and you're going to need a Kali Linux instance. If you have your own Kali Linux instance and damn vulnerable web app set up, great, you can skip this. If you don't, please utilize from the GitHub my Tartarus setup lab. It will bring everything up for you and do all of the necessary network communications and all of that, such that everything should, quote unquote, just work. You can either bring up the red team part of the guide if you're only interested in that, or if you're interested in both the red and the blue team perspectives, you could bring up the blue team part of the guide. Moving into the actual reconnaissance, these commands, if you followed along for the low security, will look familiar, utilizing Nmap and stuff. I will be getting to that in a second. However, briefly, some preamble, there are a few detection mechanisms that we are aware of within the Tartarus lab. Firstly, it's the OpenSense firewall that provides connectivity between the different firewall zones and blocks particular traffic. If, as we know, the implicit deny in any stateful or stateless firewall would be that if there isn't a rule for that particular communication, it will be blocked or dropped. Secondly, there's an Apache logging from the Apache access and the Apache access.log and error.log. That is how the defenders are getting information as to the web service. Then there is an Elastic agent to be able to get more granular process information from that endpoint. And finally, an audit deprocess to again gather more granular process information from that endpoint. We do not have the luxury of OSINT, or open source intelligence. Instead, we must rely on directly accessing the damn vulnerable web application each time we want to solicit a response or gather some information. This is critical in most engagements you'll be dealing with in the real world. You will have access to some open source information, whether that be DNS records, whether that be certificates. All of that can be used to build a better and bigger picture for what you are dealing with. In this instance, we don't have access to that, so everything that I'll be discussing throughout this will be active. If you are not using the Tartarus lab, please run this command such that you will be able to utilize throughout the rest of this guide the domain name tartarus-vulnerablewebapp.home.arpa. This, doing it like this, sudo bash c will encapsulate the whole command and give it sudo permissions so that you can append to write protected files, which etc/hosts is write protected. We then use the append operator and our target IP address. You'd replace that with whatever target IP address that is not the default for the Tartarus lab. That could be 192.168.40.1 or whatever it has been set up to, but it'll be unique to you. If you're using the Tartarus lab, you don't need to worry about this. Another small caveat, we're using .home.arpa because it doesn't leak DNS requests to recursive resolvers because we follow RFCs. Again, if you're just spinning up the damn vulnerable web app, you need to create the database. So once you have successfully logged in with the username admin and the password, you'll be prompted to create/reset the database that's needed for the rest of the guide to work seamlessly. The first tool that we will be focusing on today is the classic, the Swiss Army knife of reconnaissance, Nmap. You'll be familiar from the last time on low security reconnaissance, we did sudo nmap, very, very verbose, all tests, stealth scan or sins, half open sin scan, tac for all ports and in the specific target. That is a very loud way of engaging with the target. tac, even though it looks very small, you're sending at minimum 65,000 requests. That's a whole chunk of change. The half open sin scan is not anymore, in fact, a stealth scan, because most stateful firewalls will be logging on the first initial sin. They won't be logging the final sin of the connection, nor will they be logging the four-way teardown. They'll be logging the initial sin in the three-way handshake. The A flag for all tests, no matter what port is open, for instance, port 80 in this case, it will do all of the tests against port 80. That is incredibly loud, and it uses the default Nmap user agent, which is a big no. We know that this will trigger two rules. The pfSense correlation port scan activity, that rule will fire if there's above 1,000 blocked requests in a 5-minute interval, which the scan will do a lot more than that in a lot shorter period of time. And we also know a rule that I have modified from the upstream Sigma repository Web Apache correlation hack tool user agent. The default Nmap user agent is within that rule, so it will be flagged. Here, by way of example, this is what it would look like for the defenders. You'd see these 3 alerts, and then you can disregard the last 2 alerts. Those are elastic built-ins, and they happen pretty much every time you start a new Linux guest in this environment, but we don't need to worry about that. So that's how you could scan. Just sudo tac a ss, your happy days. What if you wanted to obfuscate that scanning such that you could blend in as much as possible? This is what the adversaries would do if they cannot rely on OSINT and they have to directly engage with the target. The 3 main approaches: send less packets, and you can read the quote, great quote, at your leisure. The first approach, send less packets. The top ports option that Nmap provides is a very simple way to do this. Sudo nmap pn, because we know the host is up. Don't rely on the ping solicitation to say that the host is in fact up. Then, as I've explained, the half 3-way TCP handshake, and then the top ports flag, you provide it with a number, and then it will scan those top ports, the most common ports that would be open in the wild. It's not a perfect list. There may be some newer ports that aren't specifically updated in the top ports. We're not going to worry about those nuances at the moment, but you can provide it with an argument of 100, 1,000, 10,000, and it will scan those 100, 1,000, 10,000 top ports respectively. You will get a result that would look something like this. It is much less detailed than you'd be expecting with the TAC A flag. You'll get port 22 is open, it's out of scope, don't worry about it. That's how Vagrant manages these machines. Port 80 is open, and that's within scope, so we will target that. But it's just saying port 80 is open, and that's it. And port 443 is definitely closed. That's all you get from this. So you have to take this information and then run further scans to be able to solicit information. But crucially, within the defender's perspective, they will see nothing. Great. This is the incantation that you're going to want to run. I will briefly explain it in the Kali instance. We can open up a new terminal and paste it in there. Again, sudo, because it has to do on the wire packet manipulations. TAC A, do all the tests. PN, the host is already up. P, we're providing it with one port, port 80, because we know that's open. And then a new flag, script args, http.useragent. This specifies a custom user agent. You can do this for the general Nmap on the default installation on your Kali instance, so that all scanning will happen with a custom user agent. Nmap advise against this, and they instead advise that you use the script args flag. But whatever you want to do, it's up to you. We then provide it with the user agent. Also note that this user agent could be an older user agent because it's a static point in time, but within here, the Chrome provides information as to what version it's using. If that version becomes too old, it's a user agent from 5 years ago, that's very suspicious. Someone hasn't updated their Chrome instance in 5 years. It's just a bit suspicious, if you ask me. So just something to bear in mind. You're going to want to periodically update this if you're utilizing it. We can then initiate the scan, and it will come back with some information for us. Instead of waiting for that, we can just look on the Shieldia guide. Here are the main points of interest: the specific port and the supported methods, head, get, post, and options. Very interesting. Get, you'd be most familiar with to be able to get a website or a resource from a remote website. you can then get for index.html or any of these other things, or like your browser would have run a GET request to get the page that you are viewing at the moment within YouTube or within the Shieldia blog. Then there's the POST method, how you can send data securely from your browser instance to the web service. As long as it's using HTTPS, then that information will be encapsulated in a way that the web server will, if supported, hopefully be able to understand. It's how you log into the main login page of the damn vulnerable web application. It makes a POST request to that endpoint with the username, password, and then user token. We don't have to worry about that too much now, but later on, I will be describing a method that we could have used that. But the supported methods, in this instance, head is what we are interested in. Again, from the defender's perspective, that particular scan yields nothing because we aren't scanning very many ports, one port in this instance, and we're using a custom user agent. Great. So we've been able to obfuscate that. The next obfuscation you could do is just slow the scan way down. If you utilize something like this, the T for threads 1 flag, this will scan at a snail's pace. Be mindful that it's going to take a long time if you do it with T1. T2 you might be able to get away with, but the adversaries, the advanced persistent threats, they have all the time in the world, and they will be doing it in a very slow and methodical manner. So just bear that in mind when writing your detection infrastructure or running your retro hunts if you're on the blue team. If you're on the red team, then you're going to want to think about these things and how you could obfuscate your activity. Finally, for today, which I'll be demonstrating, is multiple source IP addresses. We can thankfully set and inflate into the rest of the /26 network, as only 2 IP addresses are in use, the firewall and the Kali instance itself. We're going to provide it with 2 scripts. First is a script to assign all of the interfaces, because you're going to want to get the results of the scan back. This, of course, wouldn't work in a network address translated network if you're scanning IP addresses outside of your local area network. Just bear that in mind, because that network address translation that would happen on your edge, your WAN router, will, all of the source IP addresses then would be from that WAN router, and it will do some port mappings so that it's able to send all of those requests and then receive them and then translate them down to the RFC 1918 address space addresses. Just bear that in mind. So for something like that, you're going to want to use proxy chains or tunnel through different VPN endpoints or something like that, which is another whole kettle of fish that we're not going to worry about at the moment. We'll run this one script. We're going to call it, so because this script already exists, we're just going to remove it and then open a fresh one. We're going to input the contents of the script, doing the shebang so that we can utilize bash, and then all the bashisms will be able to work with this. We set a few variables up here. We then assign the interfaces. We then bring up the connection if it's down, and then assign the secondary IP addresses. So we want to exit if you're in Vim, and then X to write quit. Now that script has been written, we want to run it. So bash, and then the last argument of the previous command. It will then assign all of those IP addresses. Be warned that this will balk the network connectivity, so just bear that in mind for the time being. It's not going to balk it forever, but just for the time being. We can run this to be able to verify that it's all of those IP addresses have been assigned. You can see here, yes, they have all been assigned. Great. Finally, we're going to want to run the actual scan. This is the bash script to be able to do that. I'm going to do something similar. sh and vim scan.sh. I'm not using the cat redirection to be able to paste it from the terminal. Instead, you can use whatever flavored text editor appeals to you most. For me, it's Vim because of reasons. Again, shebangs utilizes bash, variable declaration. Then we want to set our source IP addresses. Finally, it's for loop to be able to do each of the scans for that particular source IP address, and then the port range so that it can scan from, let's say, source IP address 192.168.56.200, the source range from ports 1000, well, from ports 900 to 1700 or whatever, because it steps up in 900 port increments, as seen here, port step 900. Great. You can write that and then bash and then run it. This will then ports 1 to 900, ports 901 to, 1800, etc., etc. We're not going to run the whole thing because we don't need to worry about that. Instead, one of them do come back with a result for ports 2280, and then we know port 443 is closed. Awesome. Again, for the defender's perspective, this is going to look like nothing at all. Because if you run this ESQL incantation, you'll be able to see that where attempt count is over 1,000. We're not over 1,000 per individual source IP address. So it's going to look like nothing. This is basically what the pfSense rule does. Instead, if you do it by 100, you'll be able to see all of the different source IP addresses. So that's just something to bear in mind, that obviously we're within a network. There will be, you're going to leave a trace behind. You're going to leave some artifacts behind. That's just the nature of the beast. You're going to instead want to understand what traces you are leaving behind and how you can minimize those traces. Finally, just delete the specific interface. We're going to want to instead edit connections. Thank you very much for your service. Goodbye. Delete. Cool. Now everything should work. Again, that's the one of the searches. Just some preamble here about, if they've got 100,000 proxy chains, this really isn't the detection methodology for you. But if that is your risk profile, then you're going to need some more advanced detection methodologies. Moving on to FOSS4U full, hopefully you follow along from the low team perspective, the low security perspective, so that you would be able to run these commands without having to install everything. If you haven't, these are some of the commands you need to run to be able to install it. You'd want to get sec lists, but first you're going to want to make sure you have an up-to-date distro. Then if you're not using the Tartarus lab, make sure your etc hosts file is correctly populated with the domain name. Finally, you're going to want to install pencode. Pencode is from the same creators as FOSS4U full. It provides a way to be able to manipulate in the terminal specific word lists so that you can make them all uppercase or make them URL safe and all of that sort of stuff. Don't need to worry about it, but we can utilize it in this instance. You're going to need Go installed for that. There are installation steps online or in the previous blog posts for how to install that. Take, for instance, this specific scan. This is utilizing, or this was able to identify what methods we could utilize. Get, post, options, and head. As I've said before, head is what we are interested in this video. Having a look at the RFC, looking at ways to be able to obfuscate some of these things, came across this particular directive. The head method should behave exactly like get, except it must not. These must nots and shoulds and stuff are defined in a separate RFC that we don't need to worry about at the moment. Return any message body. What that means to me is it must reply with the specific response codes of 200, 404, or whatever else. With that, we're able to utilize or infer the fact that the specific subdirectory we enumerated earlier that set off so many alarm bells actually exists. This is the command. I will briefly describe it. Fuzz_default X, the X flag is a very common flag within curl, wgets, and all of the other Unix-like applications. It provides an interface to say, don't use the default method for this specific resource. Instead, use this custom method. In this instance, it's get, but you might be more familiar with it for post or put or any of the other methods that you could utilize. It'll default to get, but we don't need to worry about that. U for the specific URL. Fuzz, our fuzz keyword that we are injecting. We want to then also do a custom user agent because the fuzz_fos2 full user agent in the updated Sigma rule is in there and would be detected. Finally, match condition for 200 response codes. We want to follow redirects, and then our specific word list is a file descriptor for pen code. Pen code is able to then uppercase this specific file, all letters A through Z for 1 to 4 instances. So it could be A, and then Z, that sort of thing. But we want to uppercase that because a little fairy told us that all of the directories that damn vulnerable web app would be serving would be uppercase. You could go with lower and then upper and then a combination of them, but we're not going to worry about that at the moment. Instead, we know a little fairy told us that it's all uppercase. So this will scan and then be able to successfully identify that that resource is available on the server utilizing not the get method, but in fact the head method, due to the response code being 200, because everything else will respond with a 404 because it doesn't exist. For the defender's perspective, as you can see here, the return results will be DAM, so DVWA. That will be the subdirectory that we will be targeting throughout the rest of the guide. For the defender's perspective, very interesting. This is due to a premature optimization that I made within the original Sigma rule that looks for get as being the only way to actually get information from a web service. This isn't strictly correct because there are other methods that would leak information from the service. Another side channel, the undocumented main page login exploit. Due to, if you've been utilizing the damn vulnerable web app for a while, you will notice that there are errors that you would get if you leave a page open for too long and try to log in from the main page. You'll be greeted with a CSRF token invalid error. Very interesting. As well, just to elucidate this a bit more, if we were to run this Hydra command, it will look like the logins are succeeding. This is not in fact the case. All of them are failing, but it's failing in a way that Hydra isn't actually identifying. Because Hydra, in this instance, we're saying, look for the words login failed. If you don't see the words login failed, then it surely must have succeeded, but it's not going to see the words login failed. Instead, it's going to see the words CSRF token invalid. Here, we're going to utilize curl to be able to get the cookies file in the Netscape format. So we will be able to get the user token and then be able to, utilizing xargs, input that user token into our attempted login. This is all just to get the specific user token. Then it gets inputted here. And then when we run this with our xargs, it then gets inserted into there such that that user token will be an actual user token. Just by way of example, this user token is a valid user token for one of the sessions. It's all the passwords work. It's all great. Happy. No, it's all failing. Don't believe everything you see on the internet. This doesn't actually work. So why doesn't it work? Because it's utilizing the CSRF token. However, what if you just don't pass it a CSRF token? Is it able to successfully identify that something else has gone wrong? Well, based on this whole thing, you can see where we're going here. This is the normal flow that it's expecting. We're instead going to just do this. Post login.php, username, password, and then the specific user token is going to be empty. There is a nuclei template to be able to do this. It's not necessarily, from my testing, possible to do this with something like fuzzfast because when the login succeeds, it's not actually like a successful login that the server responds with. Instead, it will respond with a header to say, actually, instead of going to login.php, go to index.php. That is the matcher that we're using within the nuclei templates to be able to discern if that particular username and password combination has succeeded. So we can quickly run this because it's not using a full word list. It's just using a small subset of the rocku.txt word list. Cool. You can see here we're using a extractor to be able to get username, admin, password, and then this particular PHP session ID. If you try and log in with one of these PHP session IDs, you will see something strange. It actually leaks failed logins for other users if you log in with one of these PHP session IDs, which is quite interesting. Maybe it's another avenue to explore, shall we say. First, let's just quickly have a look at what that template looks like. Here, we're providing it with the metadata stuff we don't need to worry about. Here, the variables, we want to provide it with a list of usernames and a list of passwords. We're putting all of the passwords that would eventually succeed down here at the bottom so that we can emulate a small subset of failed logins for use later on. We're using the flow method. This is one of the newer methods with Nuclei v3 so that you'd be able to control the flow of an application much more, how shall I say, much more strictly. So we do a little for loop for user of iterate over template.users, which is defined above. We then set user to be user, and then for those passwords, we iterate over all of them. Then we will do the initial HTTP request, which is defined below. It will then do, so for username admin, it'll do all of these passwords for that username. Then for username leet, and do all of the passwords for that username. So it'll iterate over those arrays until it finds a successful or it fails completely, and then it'll exit out of the loop. We are then providing the HTTP method raw because that's just what I'm more comfortable with. We then specify what that post request will look like to login.php, host name, content type, application, the form URL encoded, accept anything, and then the specific data that we are sending. Username equals user, which is a machete variable for that specific user that we're defining above. Password similarly, and then user token, nothing, login and login. We want to then have a matcher for the specific word in the header that is location index.php. If it sees that instead of the default login.php, then that username and password combination worked successfully. And then finally, we extract the information so that it's printed nicely at the end. Great. So now that's how we can brute force the main login page and just throw away any of the CSRF stuff. It will be displayed here if you logged in with one of those other PHP session IDs that actually worked. This is logging in with, I think, the final user in the list, but I've just trimmed out the output because it's quite long. As you can see here, the normal login, great. And then this PHP session ID message is where all of like the security change to medium and stuff is printed. You'll see login failed for, and then finally you've logged in as admin. But now you're leaking another user. Well, first of all, you're leaking that user. Then you're leaking leet. And then you're leaking the next user in the list so that you're able to actually see their session IDs, which is quite, well, their session, PHP session ID information, which is quite interesting. That is primarily what I want to talk about in regards to obfuscating our reconnaissance. Now, this is the 0th post in the series because reconnaissance would normally happen at the start of, let's say, the cyber kill chain or further to the left-hand side of the MITRE ATT&CK framework. So, but it's not strictly covered within the damn vulnerable web application. However, I thought it'd be good to highlight some of the ways we can obfuscate our scanning. I'm not also in the high security stuff. We will be discussing more in depth with regards to actual on the wire advanced packet manipulation and looking at the source code of FreeBSD to be able to see exactly how FreeBSD is rejecting packets on the wire. If you find yourself in a scenario where you're in a network where the network admin hasn't correctly configured the firewalls so that it can pass traffic that is it's technically correct, but you wouldn't actually see it in a normal network. If you're in an environment like that and then you're able to pass through these firewalls, most logging would presuppose that things, I'm speaking in vagaries here because I don't want to spoil everything, but most firewalls presuppose that packets are a particular way. If you subvert that, they're not going to log those. And then if they're not logging it, the defender's not going to see it. And you can say, all right, bye. But moving along, I hope you've enjoyed. I'm going to go to the blue team perspective. If you want to join me for that video, I'll see you in the next one.